All right, I'm back for part 2 of this video. Sorry if I'm not as enthusiastic. I just had to watch the Vikings lose to the Packers. The first half was really ugly, so trying to put that behind me. Now on to some math. So we left off where we were talking about vertex form, and we were able to identify the vertex if you were looking at the equation. Now what we're going to do is we are going to take the equation and we're going to be able to graph it. So the first thing that I want to point out is that every single one of these graphs is going to be based off of the super basic function y equals x squared. So I'm just going to draw y equals x squared as kind of a template. And it's going to go through the points 1, 1, 2, 4, and 3, 9, because 1 squared is 1, 2 squared is 4, 3 squared is 9. If you go backwards the other way, it'll just mirror it on the other side. So negative 1 squared is 1, negative 2 squared is 4, and negative 3 squared is 9. So this is just the graph of x squared. So now what we're going to do is we're going to look at what happened to get from x squared to this new graph. So we recognize there that it went to the left by 2. So we're going to shift this graph to the left by 2. And it's also going to go down by 7. And what that tells us, if it goes left by 2 and down by 7, our new vertex is going to be way down here at negative 2, negative 7. So now what we're going to do is we're just going to pretend that that is the new origin, and we can go from there, go over 1, up 1, we can go over 2, up 4, we can go over 3 and up 9, and we can mirror it on the other side as well. And that would be the graph after it's been transformed. So all it did was it slid to the left by 2 and down by 7. You'll notice we're not really changing the a value at all. We can get to that later. Right now we're just looking at how that vertex changes. Let's take a look at the next one. Again, I'm going to draw my template here of what x squared looks like. So I'll put 0, 0, 1, 1, 2, 4, and 3, 9. And again on the other side. So I'm using this as just kind of a baseline for what the graph normally looks like before we change it. And now if we look over here, the only thing that's happening to the graph is it is being shifted to the right by 4 units. There is no plus or minus at the end of it, so all that's doing is it's shifting to the right by 4 units, so that new vertex is going to be at 4, 0. So I'm going to put a dot there at 4, 0. And then just pretend that that's the origin, and I'm just going to redraw that graph. So 1, 1, 2, 4, 3, 9. And then backwards. And there's the graph after it has been transformed. So once again, I'm going to pause this video here just for a second, and then, well, actually, you're going to pause the video, sorry. Go ahead and pause the video. And then when you are done, you can come back and check if you got the answer correct. All right, let's see if you got yours correct. For the first one on your own, your vertex should have been located at 3, 1. It went to the right by 3, and it went up by 1. So if you start at 3, 1, that's your vertex. And from there, should have looked something like this. And for the next one on your own, it did not move side to side at all. All that happened was it moved down by 8. So your vertex should have been located at 0, negative 8. And that's way down here. And again, over 1, up 1, over 2, up 4, over 3, up 9, back on the other side, You could also check your answer with Desmos anytime, but this would be your parabola. That was shifted down by 8 units. Now we're going to take a look at a couple more examples where we're just kind of going the other way. So now I'm going to give you the graph, and we have to find the equation that represents that graph. Let's start at the first one. We know that the vertex is at 2, -4. So what that means is that graph was shifted to the right by 2 and down by 4. So if you remember, vertex form was f of x equals a times x minus h squared plus k. For now, the a value is just going to be 1. We're going to deal with different a values a little bit later on, but for now, we're just going to ignore that a. What I want us to focus on is this h and this k. So if I know that it ended up moving to the right by 2 units, it should end up being x minus 2 squared. And then your k value in this case, since it went down 4, is going to be minus 4. So again, remember that 1 in the parentheses is the opposite of what you would think. Since it went to the right by 2, it's x minus 2. And let's take a look at the next one. It started here at 0, 0, and then it shifted left by 7, and it went up by 3. So your function is going to be f of x equals, to make it go to the left by 7, we have to put an x plus 7 inside there, squared, and then your k value, it went up by 3, so plus 3. Now I want to point out the most common mistake that I'm going to see in these problems isn't anything to do with the 7 or the 3. A lot of times you'll forget to put that squared up there. So just make sure you put a squared there, otherwise it's not a quadratic function. And the last one, that graph slid to the right by 3, and it went up by 6. So your function will be f of x equals x minus 3 squared, and then plus 6. It went to the right by 3, and it went up by 6. Go ahead on your own. I will pause, or you will pause again for as long as it takes. Go ahead and try those 3, and then we'll come back and we'll go over the answers for those. So go ahead and pause that video now. All right, we are back, and the answers to those, for the first one, it slid to the left by 5, and it went down by 4. So it's going to be x plus 5 squared minus 4. Make sure you got that squared up on top. Make sure you had x plus 5, and make sure you had minus 4 at the end. For the next one, the only thing that's happening to it is it's sliding to the left by 1. So to make it slide to the left by 1, we have to do x plus 1 squared. And then it didn't go up or down, so that's all it's going to be. So I'll put equals f of x. Doesn't matter which side I put equals f of x on. And the last one, we'll put our Vikings colors here. It slid to the right by 4, and it went all the way down by 12 to get to your vertex. So we have f of x equals, to make it go to the right by 4, it's going to be x minus 4 squared, and then went down 12, so minus 12. And everything that we've done so far has had an a value of 1, but it's going to be pretty rare that you're going to have every single graph that has an a value of 1. So now we're going to see what happens when a isn't equal to 1 and how we can solve for that a. So for the first example, we have a graph shown that has a minimum, that's the vertex, located at -3, -5. And we also know one other point that's on the graph. All we need to know is one point other than the vertex, and then we can go ahead and solve for a. So let's start with our function f of x equals a times. Now, if our vertex is located at -3, -5, we know that it had shifted left by 3 and down by 5. So I'm going to put x plus 3 squared because it went to the left by 3, and it went down by 5. So we have f of x equals a times x plus 3 squared minus 5. All I did was I plugged in the vertex there. Now what I'm going to do is I'm just going to plug in one other point that was on that graph. And that point we have was -7, 3. That -7 is the x-coordinate, and the 3 is the y-coordinate. The y-coordinate we can just replace with f of x. F of x essentially just means the y-coordinate. So I'm going to replace f of x with 3. We don't know what a is. We'll leave it as a. I can replace x with -7 and then write out the rest of it. Now it's just a matter of simplifying and solving. So we have the -7 plus 3 is going to be -4. If you take the -4 squared, it's going to become 16. So I'm going to call that 16a minus 5. Here's where, kind of throughout the course, I'm going to skip a couple steps as I'm solving it, as most of you probably would too, but to solve this, I would just do +5 and +5, so I won't show that step, but if you just add 5 to both sides, we get 8 equals 16a. And if you divide by 16, divide by 16, we end up with a equals 1/2, or 0.5. If you write it as a decimal or as a fraction, either one is fine with me when it's an exact answer like that. So our final function, after you solve for a, you still have to write it all out. It's going to be f of x equals a we can now replace with 1/2. Then we can replace our x plus 3 squared and minus 5. And that's the function that's represented by that graph. And we'll do one more. So once again, we have our vertex, we can plug that in. So we have f of x equals a times x minus 2 squared plus 40. So the vertex is located at 2 and 40, so we just plug in that vertex. We also know one other point on that graph, which is 0, 24. So the y-intercept is at 24. We're going to plug that point in. So f of x gets replaced with the y-coordinate. That's 24. A we don't know. We're going to solve for it. X I can replace with 0. And then write out the rest of it. And then simplify and solve. If you have 0 minus 2, that's going to simplify to -2 squared plus 40. -2 squared just becomes a 4. So we get 4a plus 40. We're going to subtract 40 from both sides because we're trying to get a by itself. So that's a -16 equals 4a. If you divide by 4, we get an a value of -4. And that makes sense because that graph opens downwards. So we should have an a value that's negative. And then we just write out our final answer is f of x. Plug in your a of -4. And then plug in your vertex that we had earlier. X minus 2 squared and plus 40.